Hello and welcome. In this video we're going to take a quick look at how we can gather information about the volumes that are on our machines. This is going to be useful so you can see what drives are connected to your machine, how much space is being used on them, how they're allocated to volumes. You'll then use this in combination with logical volume management to be able to better manage and flexibly manage the storage available on your machines. So we're going to look at a handful of commands because, well, before you start making changes to a machine's file system, you should be fully familiar with how it's actually currently configured. And that's actually pretty much true of any command. Before you start making changes, you should be gathering information so you're sure you're familiar with the situation on the machine before you start modifying it. Now the df command that I've listed here, I described that in a different video, so I'm not going to repeat that here, but very useful for seeing the volumes attached to your machine, how large they are, how much of that space is being used. lsblk is going to list for you your block devices, the disks that you have, and how they are partitioned. So we'll head over to another machine, and I will sudo lsblk. And this is going to let me know, and I'll get into the details of this in a moment, I effectively have two hard drives connected to this machine, SDA and SDB. SDA is broken down into two partitions, SDA1 and SDA2. SDB is broken down into four partitions, SDB1, 2, 3, and 4. And some of those may be broken down a little bit further, but that requires logical volume management stuff that is the purview of a separate video. But this lets us see the drives connected to our machine, how big they are, whether it's the disk or a partition of that disk or a logical volume that is existing inside of that partition, and potentially where this is actually mounted into our machine. So is this currently accessible to our users? So useful, broad information. SSM list is going to give us a significant amount of information about, is this currently set up for logical volume management? In fact, all of these commands are going to do that. So PVS, VGS, and LVS are going to give us the same information that SSM list does in a slightly different format. The big difference is SSM list displays it all at once, displays a bit of extra information, including things that aren't necessarily part of LVM, and you have to manually install the SSM command as part of the System Storage Manager package. So let's do that now. So if I say sudo SSM list, we get this nice display, if I scroll back up a bit, showing me the devices that are on my machine and how they are partitioned out. So as we saw with the lsblk information, I have this device SDA, which is partitioned into SDA1 and SDA2. I have SDB, which is broken down into four partitions. For each of these, if there is any free space, it's going to let us know. Actually, I will rephrase that. It's not for each of these. It's only going to show us the space information about the ones that are set up for logical volume management. So I have this SDA1 partition that is 1 gigs. That is just a normal partition set up for, well, booting the machine. These others that are set up for logical volume management, well, I mean, it's showing us the space for each of these objects, but in addition to that, it is showing us how much space on that object is free, how much is currently in use. So you can see this one is currently fully allocated. These two down here are currently not being used at all. So this is something where once we get a bit further into logical volume management, if I needed to reallocate some space immediately, I know that I have these two volumes here that okay, they only have 500 megs. Realistically, we'd probably be looking at volumes with 500 gigs, but I don't have that available on a demo machine. But knowing that this is currently unused, we could easily reallocate that space elsewhere if we needed it. So this tells us about our logical volumes. It also tells us about our volume groups, also known as our pools. It tells us, I'm trying to highlight, not resize, it tells us their name, that they are in fact a LVM pool, how many physical volumes make up this pool, how much total space is free within that pool, how much is currently in use, and how big the pool is in total. And you can correlate this information to what we saw in the first block of data here. This archives pool, we can see 4 physical volumes that are part of this archives pool. They're each 500 megs, so they combine to a total space of not quite 2 gigs because a little bit of space is used up in just management and metadata. But we can see there are 4 devices with a combined total of 1.35 gigs free, which if we added up these, we should get something pretty close to that. We have a second pool that has 1 physical volume attached to it that, well, I've used up all 19 gigs of it, and that certainly is the same information we saw in that first block of data. The third piece of output is the logical volumes. So I've taken pieces of that volume group and portioned them out to make these volumes. We can see what the volume is called, where it is mounted on my machine, what pool it comes from, how big it is, how it's formatted, if it's formatted, the file system size inside that volume size. Yes, you could actually have the file system in there, not take up the entire volume. That's a bit more advanced though. And how much of that space is actually free. So even though way back up here, this is telling us there is no free space on that physical volume, that's because we've taken all 19 of those gigs and we've said that is part of this logical volume. And we've created a file system inside that that is, well, there's one at, we've created a volume inside that at 15, and then 2, and then 2, combined a total of 19 gigs. If we really needed to save some space, we can look at this and say, wait a second, I have 10 free gigs there, so I could shrink this file system and reallocate that space somewhere else. And this goes back to what I was saying in another video about LVM does make reallocating space a little easier than traditional file system management. When we actually start trying to do that, we could take some of this space and reallocate it somewhere else while the machine is running, while users are using it, which is a definite advantage over the older style. So this just lets us gather information about our volumes, our physical volumes, our logical volumes, our volume groups. Much of the same information can be gathered from PVS, VGS, LVS. So sudo PVS for physical volumes. You'll notice this isn't showing me the /dev/SDA, the thing that represents the whole drive. It's not showing me the entry that was not actually a logical volume. It's just, not a physical volume. It's just showing me these partitions that are specifically marked as physical volumes. So that roughly 19 gig /dev/SDA2, we can see the physical volume name and the volume group that it is assigned to. And for each one, how big the partition is, how much of it is free. so not currently allocated in use by anything. If we take a look at VGS, volume groups, we get the name of each volume group, how many physical volumes are currently attached to this group, and how many logical volumes, how many chunks of space we have portioned out. So we can see how big that volume is in total, so the total space available to it, and how much of that space is currently not actually allocated to anything. And finally, LVS, logical volumes. We can get a display of our logical volumes, so what they're called, the volume group that they belong to, and how big that logical volume is. So as part of that, we were looking at things called, well, like SDA, SDB, SDB1. This is because the file systems, the hard drives that are attached to our machines, the actual file system is an especially formatted file on that hard drive called a block device. And these are all going to show up in /dev, and they will have names, specific names, inside that directory. Your first SATA, PATA, SCSI, or USB attached hard drive will show up as SDA. The second one is SDB, third will be SDC, and so on. Now that name, /dev/SDA, /dev/SDB, whatever, that represents that drive in its entirety. When you start partitioning that drive, you then get an extra number attached onto that. So the first partition on the first drive, you would have SDA1. The second partition on it would be SDA2. The third would be SDA3, and so on. And those numbers, that count up of 1, 2, 3, up to whatever, that is unique to each drive, so we can have SDA1, the first partition on the first drive, SDB1, the first partition on the second drive, SDC1, the first partition on the third drive. Potentially, you may also see virtualized storage, which would show up as VD, so virtual drive, but then the rest of the rules apply, so A would be the first of these, B would be the second, C would be the third, and if you start partitioning those, you get VDA1, VDA2, VDA3. So if we go back to some of our output here, perhaps say LSBLK, this SDA, that represents the first hard drive attached to this machine. And it has two partitions, SDA1, SDA2. SDB is the second hard drive attached to this machine, and it has four partitions, SDB1, SDB2, SDB3, SDB4. So this is nice and standardized, so we can easily look at it and say, okay, this partition is part of this drive. And if we head over and take a look at, actually I will probably need sudo for this, so ls/dev, we can see there's SDA. It's the special block device file that represents that drive. And we can see files that represent the partitions of that drive, SDA1, SDA2, and of course for our second drive, it's four partitions. Potentially, you might also see, if I had virtual storage attached to this drive, over here we might see VDA, VDB, VDC, and so on. You could also potentially see some other letters. There are other ones for NVMe drives, for SD cards and micro SD cards. They're beyond the scope of this video. We're just paying attention to sort of standard drives. Maybe once NVMe becomes a little more common, I'll make a video where we talk about that in detail. So what we've looked at in this lesson, in this video, was just a few commands that we can use to start gathering information about the devices that are already connected to our machines. Where are they? what file represents them, and are they subdivided into partitions? Are they part of a volume group? Is that volume group allocated out into logical volumes? So we need this to be able to understand what's currently going on our machine so that we can start making correct decisions, accurate decisions about how we're going to modify the storage on that machine. Actually doing that, though, is a topic for another video, and I'll see you there.